Hello, and welcome to Echoes of the Forgotten Earth. Tonight I want to lead you somewhere still, somewhere beneath the constant murmur of our cities and far below the thin smear of time we like to call history. Down there, in the profound quiet of the planet itself, lie stories we may never hear. And yet now and then, you can't help but ask yourself whether those stories are still waiting, concealed in the rock and soil beneath our feet. What if we are not the first? At first, that question feels almost like a puzzle, the kind of idle idea you dismiss with a smile. After all, we know where we came from, don't we? We can trace a clear path from chipped stone tools to ziggurats and pyramids, from movable type to rockets and orbiting satellites. The sequence seems obvious, but then you remember something else. That line is narrow, breakable. It runs back only a few thousand years and then it vanishes, swallowed by the haze of prehistory. Before that point, we have only skeletons, scattered implements, and the faintest marks of campfires made by humans who walked this world long before us. And if you step even farther back, leaving behind the comfort of human history entirely, the true scale of our world begins to appear. The Earth is around 4.5 billion years old. That is not a figure the mind can easily grasp. It is a stretch of time so immense that everything we have ever achieved occupies only the thinnest slice of it. A brief instant that would disappear if you blinked. That is where the question begins to shift. Because if the Earth is that ancient, why are we so certain that nothing comparable to us came before? Not just animals with claws, fangs, and shells. Not only forests and seas filled with bizarre alien-looking creatures, but something more. Something capable of thinking, of shaping its surroundings, of leaving a mark, if only for a short while, before time, and the planet itself erased the evidence. This is not merely a tale about what could have occurred tens of millions of years ago. It is a story about how the Earth behaves. Our world is not a museum. It does not preserve its past on tidy shelves for anyone to inspect. It wipes. It reuses. Continents drift like rafts over a deep hidden ocean of molten rock. Mountain chains rise skyward and then are worn down grain by grain. Seas engulf whole coastlines and then shrink away again. If you raised a modern metropolis today, left it untouched, and returned after 1 million years, you would not find its shattered towers. You would not even discover its dust. You would see bare bedrock and soil. Perhaps far below, there might be the faintest chemical stain locked inside the stone and nothing else. And 1 million years, in geological terms, is almost nothing. Stretch that span to 10 million, 50 million, 100 million years, and you start to glimpse what deep time actually does. Civilizations, if there were any before our own, wouldn't simply crumble and sit. They would be folded into the moving skin of the Earth, ground and remade until only the tiniest, most resilient traces persisted, hidden in parts of the planet we have barely begun to examine. Scientists even have a name for this thought experiment, the Silurian hypothesis. It is not a declaration that earlier civilizations definitely existed. It is a carefully posed question. If an intelligent species had dominated the Earth millions of years ago, would we be able to detect it today? And the honest answer is complicated. Most of the things we instinctively treat as evidence cathedrals, engines, statues, skeletal remains would long since have been annihilated. Even the highest skyscrapers would have collapsed into dust ages ago. Highways would be scoured away. Rivers would abandon their old channels. Deserts would bury what little remained. Yet some signatures endure longer than marble or iron. When you look back through Earth's history, you don't just encounter fossilized bones. You see recurring patterns, chemical imprints, changes in the air itself, subtle indicators that something in the system shifted. Even when no visible trace remains, if a civilization burned fuels, processed metals, or altered the climate, tiny fragments of that story could still be preserved in layered sediments and rock formations. Not a smoking gun, not a neat inscription we could point to and say, "Here, this proves it," but a faint resonance of something out of the ordinary. So far, nothing like that has been conclusively identified. But then again, Why would it have been? We have examined only a minuscule portion of our planet in real detail. The majority of the seafloor remains poorly charted. Most of the deep crust lies totally beyond our direct reach. We are surface creatures, scratching lightly at the upper skin of a world that has been remaking itself for eons. If there were older narratives, they would likely lie buried far deeper than anything we routinely see. That is what makes this question so disquieting. We are accustomed to thinking of the planet as ours. We imagine history as a single straight arrow that begins with us and will ultimately end with us. But perhaps the arrow is an illusion. Perhaps the pattern is cyclical instead. Emergence, expansion, collapse, erasure. In that case, we could be just one brief episode in a book so vast that none of the earlier episodes are remembered. And strangely, that possibility is not entirely grim. In one sense, it is almost comforting. Because if there was something before us, then our appearance is not purely a random accident. We become part of a much longer narrative, one that stretches well beyond the scope of any human calendar. A story inscribed in rock and in silence, waiting for anyone patient enough to learn how to listen. Of course, none of this implies that there were shining cities beneath the dinosaurs' feet or intricate machines entombed miles below ground. If anything did come before, almost everything it built or was would have been scoured away. What survived would not resemble an abandoned metropolis. It might not even resemble a recognizable fossil. It would be a razor-thin layer of difference trapped in stone, something so subtle that only careful scientific tools could detect it. Still, even if the odds are tiny, the sheer age of the Earth opens up astonishing room for speculation. 4.5 billion years is plenty of time for the seemingly impossible to occur, not once, but many times. Long enough for entire worlds of life and thought to rise and then vanish, each leaving nothing on the surface but a breath of suggestion beneath the soil. So we begin here, with a question that resists easy solutions. We will follow it downward, through stacks of rock and gulfs of time. We will examine how the planet erases its own history, and how a trace, if it ever existed, might yet be concealed within that erasure. Because if there is even the faintest possibility that we are not the first, then every outcrop, every layer, every quiet and overlooked corner of this world becomes more than mere dirt and stone. It becomes a page from a chronicle older than anything we currently remember. And if nothing else, that perspective reminds us that sooner or later, we too will be absorbed into that chronicle. One more stratum in the Earth's long, unhurried memory. If we want to grasp why the question of forgotten civilizations lingers, we have to begin with time itself. Not the humankind that ticks on calendars and wristwatches, but the immense, alien timescale that belongs to the planet. Human history, even in its most generous definition, is almost nothing when set beside it. Compress the Earth's entire existence into a single day. In that day, every palace, every war, every recorded civilization from the first tablets to the present moment would show up only in the last few seconds before midnight. Everything else, the endless collision and drift of continents, the advance and retreat of seas, the rise and extinction of entire families of organisms, would unfold in deep, uninterrupted quiet long before we arrived. And quiet is precisely what deep time tends to leave behind. For every 1,000 years that pass, storms and sun grind down mountains, rivers shade new valleys, and the ground itself creeps and slides. The Earth's surface is not a fixed library of events. It is a constantly repainted canvas, forever covering its earlier images. If something lived here, built here, and thought here millions of years ago, its afterimage would not be a set of ruins we could stroll through. It would be spectral, almost intangible, discernible only in the chemistry of rocks and sediments. We often overlook how much the Earth has already deleted. Consider the astonishing fact that almost none of the surface you see today dates back to the earliest chapters of the planet's story. The crust we tread on is youthful compared to the world as a whole. Most of the primordial crust has been consumed by plate tectonics, pushed downward into the mantle, melted, and then cast up again in transformed form. Whole continents have assembled and broken apart. Mountain ranges that once rivaled or exceeded the Himalayas have been worn to nubs and buried roots. If a civilization arose in some remote geological age, how could it have withstood that relentless tectonic churn? The honest answer is, it almost certainly couldn't. Even the fossil record, the most robust archive of life we possess, is harrowingly incomplete. We are acquainted with only a small portion of the organisms that ever lived, because most of them left no fossil at all. For every splendid skeleton in a museum hall, countless others were broken, dissolved, or never fossilized to begin with. Now imagine not fragile bone, but wood, plaster, metal, glass, buildings, machines, everyday objects. They would disappear on timescales far shorter than those that erase bones. Yet the past leaves marks by other means. When researchers examine the rock record, they do not find only shells and teeth. They encounter clues like a narrow band of clay enriched in iridium, a rare element on Earth's surface that tells of the asteroid strike that ended the dinosaurs' reign. They find banded iron formations that memorialize the moment when oxygen flooded the atmosphere billions of years ago, when living things altered the chemistry of the entire planet. These are the types of traces that persist, not statues or walls, but chemical stories impressed into stone, like ghostly fingerprints that never quite go away. If an earlier technological civilization left any heritage at all, this is where we would expect to glimpse it. Not as a buried metropolis beneath dunes, but as strange, localized shifts in the geologic and chemical record. A sudden, unnatural imbalance in carbon isotopes, hinting at vast amounts of carbon suddenly released. Anomalous accumulations of rare metals, the scatter left behind by intensive mining or industry. Such anomalies would not leap out to the casual observer, but to a trained geologist they would stand apart as quiet, stubborn intrusions in the data. And even then, the signs might be so delicate that we would fail to recognize their true nature. We are only now learning to read the planet's deeper chapters. Barely more than a century ago, we did not know how to calculate the ages of rocks. We had no real grasp of mass extinctions or that much of the globe had at various times lain under glaciers or shallow tropical seas. Each generation decodes a few more pages of deep time, but the majority of the volume remains closed. That is why the ghosts of forgotten epochs are so easy to miss. They do not stand on the surface demanding attention. They hide in places we rarely look on: the abyssal plains of the oceans, in the buried roots of ancient mountain belts, in the desert outcrops where wind has stripped away younger layers and revealed older stone beneath. These are the settings where the earth stores its oldest recollections. Even there, the memories are cracked and scattered. And in an odd way, we ourselves are potential ghosts of this kind. If someone, or something, were to come long after us, millions of years in the future, they would not behold the world we take for granted. They would not see skylines on the horizon, or wander through intact libraries, or pick up the devices we peer into every day. They would instead encounter a peculiar thin band in the rocks. Within that band, they might note traces of metals in places where no straightforward geological process should have placed them. They might recognize a brief, sharp disturbance in the delicate balance of atmospheric gases, frozen forever in the chemical record. That is all. That would be our ghost. The thought feels alien because we are wired to imagine ourselves as enduring, but the planet does not share that illusion. It inters its past without ceremony. It has done so countless times and will go on doing it. Every footprint, every building, every subtle imprint of our presence is temporary. And if that is true for us, it must have been true for any predecessors as well. This is what makes the notion of a lost civilization so haunting. It is never only about them. It is just as much about us. It compels us to picture the world not as a stage set exclusively for our story, but as something much older, far stranger, and indifferent to who happens to be walking upon it at any given moment. We are here briefly, then we fade, the Earth continues, carrying its secrets buried beneath new layers of stone. And perhaps that is why the idea is at once unsettling and oddly soothing. Because if others existed before us, then they are not fundamentally different from what we will one day become. A thin line in rock, a handful of faint signals recorded in the deep memory of the planet. Nothing more and nothing less. But before letting that realization settle too deeply, we should ask how those memories are created in the first place, and how easily they are wiped away. Because if we want to comprehend the ghosts of forgotten ages, we must first understand the forces that entomb them. Grounded imagination about what life might plausibly have produced, given enough time. We are quick to see ourselves as singular. Yet evolution has no rulebook that says intelligence can only arise once. Life has been experimenting on this planet for billions of years. It has shaped creatures with armored plates like stone, and others with bones as delicate as air. It has given us predators that dominated the oceans for hundreds of millions of years, only to snuff them out in the wake of some cosmic or volcanic disaster. If thinking minds emerged once ours, then it is not absurd to wonder whether something comparable might have emerged earlier in forms that left only the tiniest echoes behind. Consider simply that mammals have not always been in charge. For the majority of Earth's history, reptiles ruled the continents and seas, while strange, feathered and featherless creatures dominated the skies. Before them, there were long eras led by life forms even stranger to our eyes. Fish with gaping, armor-framed jaws, forests of colossal plants that resemble none of our modern trees, insects so large their shadows would have loomed above us. Intelligence, if it ever arose in those ages, would not have shared our appearance. But there is no reason it would need to. A mind capable of modeling and manipulating its world does not require a familiar shape. Some scientists have even speculated that certain lines of dinosaurs, had they been given more time, could have evolved extremely complex brain structures. That is conjecture, of course, but so too is the confident belief that intelligence never appeared before us. If natural selection can produce flight, echolocation, and organisms that glow with their own light, why not thinking brains in some long-vanished ecosystem? Perhaps not often, but at least once, in some window, when conditions allowed it. If such an earlier civilization did exist, its course might have diverged dramatically from ours. We imagine dense cities because cities are what we know. But perhaps they lived in a way that left little physical imprint. Maybe their tools and structures were fashioned from materials that decayed as quickly as wood or flesh. Perhaps they learned to master their environment without carving the kind of broad industrial scars we are now etching into our planet. If so, their entire presence could have slipped into the geological record almost without a footprint, their story ending in unrecorded stillness long before our first ancestors ever learned to walk. Even if they reshaped their world more aggressively, in ways more akin to what we are doing today, time would still be against them. 1,000,000 years is enough to flatten mountain ranges significantly. 10 million years can drown whole continental margins. 50 million years can alter coastlines, climate, and entire ecosystems beyond recognition. A civilization that blossomed and fell within that kind of timescale might easily have had its remnants buried miles deep or obliterated outright. What would remain within our reach might be no more than a lingering idea that something could have been there. Still, there are unsettling intervals when we unearth things that briefly seem to defy easy explanation. Oddly shaped objects found deep in mines. Stones split open that reveal patterns suggestive of deliberate work, though often they prove to be quirks of crystal growth or erosion. These are not convincing evidence. In most cases, natural explanations are sound, and the few unresolved cases are likely coincidences. But they embed themselves in our imagination because they touch something older than data. The quiet sense that a planet this ancient must hold more chapters than we currently know, hidden beneath layers of time we have only started to peel back. Even our own existence fits remarkably well into such a pattern. We have been here for an eye blink in geological terms, and already we are leaving marks that may persist for millions of years. Novel alloys and processed metals, synthetic molecules, plastics, and a sudden, unnatural shift in atmospheric chemistry. These are being pressed into sediments and rock, a kind of message for anyone who might one day study the planet after we are gone. If we can imprint the Earth so noticeably in such a short span, who can say it has not happened before? And if it did, we might not even recognize it when we saw it. If a civilization had risen 50 million years ago and left behind traces we don't yet know how to interpret, we might simply categorize them as odd geological features. For all we know, we may already have built over them, driven highways across them, or ground their last remnants to dust while mining, never understanding what we destroyed. That is the humbling aspect of this question. It suggests that we are not only late arrivals on an old world, we might also be forgetful inheritors, living on a planet that has already had previous tenants. The Earth is old enough to have lost almost all memory of them, but not so old that it could not host others again. And that possibility, however faint, subtly transforms how we look at the ground under our feet. The next time you gaze out across a barren desert or stare into the dark, cold reach of the open ocean, or look up at the jagged profiles of old mountains, you might remember that this world has likely told more than one story. Ours is just the one we can currently hear. Others may have unfolded long before, erased so completely that only the softest whisper remains in stone. And if that whisper truly exists, then somewhere in the planet's deepest places, the Earth may still be keeping their secrets. If there is one thing this planet excels at, it is forgetting. We often picture the Earth as a vast archive with layer upon layer of rock preserving a perfect record of everything that has ever happened. In reality, it is more like a relentless editor, constantly revising, crossing out, and writing new passages over old ones until only a few scattered fragments survive. To understand why, you need to look at how the Earth is built. The ground that feels solid beneath you is, in reality, a thin, fractured shell. That shell is divided into great tiles tectonic plates that drift atop a hot, deformable interior. The plates move like slow rafts on a hidden sea of semi-molten rock, crashing together, pulling apart, and grinding past one another in a cycle that has been operating for billions of years. Where plates collide, mountains rise. Where they separate, new ocean floors spread outward from ridges. All the while, old crust is pushed downward into the mantle and recycled. This ceaseless motion is why truly ancient surface rocks are rare. Most of the crust we stand on has been created, destroyed, and remade many times over. Go back hundreds of millions of years, and you would see the continents in different shapes and configurations, the oceans and other basins, even the atmosphere holding a different mixture of gases. Whatever might have been written on those long-vanished surfaces is now deeply buried or gone. Imagine a city built in our time. If people disappeared and left it to the elements, nature would begin reclaiming it almost immediately. Within a few centuries, trees would punch through pavement. Roofs would fail. Streams might shift into streets. In 10,000 years, you might still find scattered masonry or twisted remnants of metal. But after 1,000,000 years, nearly all of it would have been pulverized and dispersed. Now run that clock forward 10 million years, 50, 100. Tectonic forces would have shifted the ground. The site might be under a mountain belt or on the floor of a new sea or consumed at a subduction zone and melted into magma. At that scale, the whole concept of ruins stops making sense. Nothing persists in recognizable form. This is why, if a civilization existed long before ours, the primary reason we see no obvious trace is simple. The Earth itself has erased it. Even fossils, which are far more robust than buildings, are rarely preserved for extremely long intervals. The fossil record thins dramatically as you go back in time. Only a tiny, lucky subset of organisms is ever fossilized, and many of those fossils themselves are destroyed when rock is uplifted, folded, or heated. Geologists talk about unconformities, gaps in the rock record where millions of years are simply missing. These gaps exist because erosion stripped away older layers before new ones were deposited atop them. Imagine tearing out whole chapters of a book and then continuing to write. That is what the Earth has done over and over. If an ancient civilization happened to occupy one of those lost surfaces, its every physical trace could have been removed before the next page of rock was even laid down. Some things are not erased so quickly. They are buried deeply enough to be shielded from rainfall and wind. But even then, they are not secure forever. Subducting slabs drag rock downward. Drag. Heat and pressure transform its sediments become solid stone. Stone recrystallizes into new types of rock, and some of it eventually melts to form magma. When that magma cools at or near the surface, it forms new crust, starting the cycle again. If we were to disappear tomorrow, the same engine would eventually absorb nearly everything we have ever built. This is precisely why scientists hunting for signs of deep past events do not primarily search for intact artifacts. They look for chemical fingerprints. The asteroid that ended the dinosaurs' age left behind only a subtle physical trace at the surface, and its crater was difficult to confirm. But scattered in a thin layer all around the globe is an enrichment of iridium, a metal rare in Earth's crust but common in meteorites. That chemical anomaly was enough to reveal the event. In an analogous way, if there had been a technological civilization far earlier in Earth's history, we would likely detect it, not through statues or devices, but with chemistry. Small, persistent anomalies entombed in rock. Yet even here we face limits. The ocean floor, which covers most of the Earth, is geologically young. Almost all of it is less than about 200 million years old, constantly renewed as older seafloor dives back into the mantle. Any record older than that is gone. On land, we do have rocks dating back billions of years, but they are rare and often so altered by intense heat and pressure that whatever information they once held has been largely overwritten. That is what it means to live on a dynamic planet. The ground seems unmoving only because it shifts slower than our lives. Given enough time, nothing on the surface stays where it is. The familiar continents are simply temporary configurations. In another 100 million years, they will likely be fused into new supercontinents or rearranged into unfamiliar shapes. Whatever we build now will move with them or be devoured. Seen this way, the absence of obvious evidence is not decisive. It doesn't prove that previous civilizations never existed. It only reveals how efficiently the Earth cleans its slate. 100 million years is long enough to remove almost every direct trace, leaving at best faint clues in places we have checked only briefly. Still, for all this recycling, the possibility remains that something subtle might survive. Somewhere, sealed in some overlooked layer beneath land or sea, there could be a small irregularity, a strange metal ratio, an unusual isotopic pattern, a distribution of elements that doesn't quite match any known natural process. Not a clear message, but a ghost. And if we ever found such a ghost, it might be the only surviving voice from a world that lived and died before we ever formed the question. Whether we are prepared to search for such ghosts is another matter. Once you accept how completely the planet erases its past, you begin to sense how many other things it might have brushed away unseen. And that thought lingers. Because if the Earth has already done this many times over its long life, there's no reason to think our turn will be any different. One day, long after we are gone, our landscapes will be nothing but grains in the rock record. Our machines will be reduced to their base elements. Our history will be folded into the same layered archive that quietly holds everything else. One day, we too will be only a thin, unusual horizon in the stone waiting for some distant investigator, if any exist, to wonder who left it there. The more you dwell on how mercilessly the Earth overwrites its own story, the more a certain idea takes root. It is not a casual notion. It even has a formal name, given to it not by novelists, but by working scientists who decided the question deserved rigorous treatment. They call it the Silurian hypothesis. The name is borrowed playfully from a piece of science fiction about intelligent reptilian beings who supposedly flourished on Earth long before humans. But under the whimsical reference lies a serious inquiry. If an industrial civilization had appeared on Earth in the distant past, how could we detect it now? And just as importantly, is it possible that we would fail to detect it even if it had existed? The Silurian hypothesis is not a claim that such a civilization truly did arise. It offers no direct evidence that it did. Instead, it serves as a test of our methods. It asks whether our current ways of reading the geological and chemical record are actually sufficient to rule that possibility out. Because if they are not, then the question must remain open, however slightly. When researchers first framed this hypothesis, they began with something close to home: our own civilization. Even at this early stage in our industrial era, we are already inscribing signals into the Earth that will likely long outlast us. By burning vast quantities of fossil fuels, we are altering the balance of carbon in the atmosphere and in the oceans. That altered balance will eventually be locked into rock strata, forming a clear chemical marker that could persist for millions of years. We are also extracting and scattering metals on a planetary scale: copper, aluminum, lead, rare elements used in electronics, in quantities and patterns never produced by natural geological processes. We manufacture synthetic compounds that no volcano, no lightning strike, no normal weathering process could generate. Complex plastics, industrial chemicals, and contamination byproducts. Though many of these substances will degrade, some fraction may still end up buried and preserved in deep sediments as tiny, enduring traces. If we were to vanish, the visible aspects of our world would fade, but those deeper signals, those changes in chemistry would remain. They would form a thin global layer testifying that, for a short period, something unusual happened here. If that is what we can accomplish in a few centuries of industry, then the next question follows naturally. What if someone else had reached a similar stage long before us? The scientists who elaborated the Silurian hypothesis, Gavin Schmidt and Adam Frank, handled the idea cautiously. They understood how outlandish it might sound. They made it clear they were not asserting that a prior civilization existed. Instead, they asked, if it had, what traces would it leave? And how long would those traces remain legible? Their conclusions are at once reassuring and disturbing. Reassuring, because it appears that our own impact will indeed leave a recognizable mark in the geologic record. Disturbing, because that mark might be surprisingly ambiguous to anyone who did not already suspect that a civilization once existed. Imagine a future scientist, tens of millions of years from now, splitting open a layer of rock from our era. They might detect a sharp uptick in certain industrial metals spread across many regions. They might register a pronounced shift in carbon isotopes, signaling a short, intense pulse of carbon released into the atmosphere and oceans. They might even find degraded remnants of synthetic molecules. What would they make of these findings? Would they interpret them correctly as signs of a brief industrial age? Or would they propose some other explanation, perhaps a rare type of volcanic event, a global episode of unusual sedimentation, or an anomalous period of ocean chemistry? Without unmistakable artifacts, without bones or tools embedded in situ, such signals might be written off as strange, but natural. This is what makes the Silurian hypothesis so unsettling. It forces us to admit that even if a civilization had appeared long before humans, we might not be able to recognize its fingerprints in our current data. The Earth is simply too old, its record too fragmented, yet there are promising places to search for such subtle evidence. Deep ocean sediments are among the most continuous archives we have. They accumulate layer by layer, relatively undisturbed, preserving a chronological record of global conditions. If an ancient industrial phase occurred, its chemical traces might still lie hidden in such sediments, now buried beneath thick stacks of younger deposits. We might also scrutinize ancient coal seams and other fossil fuel deposits. A technological species would likely have discovered and exploited accessible energy sources. Their activity could have left anomalous gaps in those deposits or chemical byproducts inconsistent with purely natural formation and burial. Even unusual erosion patterns or unexpected mineral concentrations might hint at extractive activity, though distinguishing them from natural variations would be extremely challenging. The truth is, A serious search for such evidence would not be about finding grand ruins. It would be about hunting for subtle irregularities, signals almost indistinguishable from noise. That is precisely why the Silurian hypothesis stays lodged in our minds. It is less about speculating wildly and more about humility. It reminds us that our tools and our knowledge are still crude compared to the scale and complexity of the planet's history. We are one brief chapter in a book that began billions of years ago, with most of the earlier sections torn or charred. We cannot easily declare, with absolute confidence, that no other chapters contain something resembling us. We can only keep refining our reading of the surviving pages, and in doing so, we change ourselves. We are pushed to acknowledge that our time here is short, that the Earth has seen more than we can ever reconstruct, and that one day, our own civilization will likewise shrink into a faint, ambiguous signal in stone one, that future eyes may or may not interpret correctly. If there is a lesson here, perhaps it is this: if we care about being remembered in any form, we must understand that it will not be our monuments or our stories that endure. It will be what we imprint on the planet's deepest record, the chemistry of its air, water, and rocks. That is the language in which the Earth truly keeps history. If the Silurian hypothesis teaches us anything, it is that time does not compromise. It breaks down everything, even its own evidence. Yet if a civilization older than ours ever did exist, some small part of it might still persist, not as recognizable relics, but as what we might call fossils of fire and steel. These would not be fossils in the usual sense. You would not mount them on a museum wall. They would be hidden far underground, stripped of form and identity, reduced to the bare residual signs of their materials. But traces of them could, in principle, remain. Looking at our own world, we can already infer the outline of what we will leave behind. Think of steel, the core of our bridges, ships, skyscrapers. Abandoned to the elements, those great frameworks would not long endure. Rain, salt, and oxygen would steadily corrode them. Within a few thousand years, what was once a tower or a shipyard would collapse into vortices of rust. Those corroded fragments would sift into the ground, washed into rivers, carried to low places where sediments accumulate. Buried beneath successive layers and subjected to pressure over millions of years, those fragments could be transformed into iron-rich rock. To a distant geologist, those iron bands might look unremarkable, except for the peculiar ratios of alloying elements: nickel, chromium, molybdenum. Those subtle anomalies would be the whisper of our once extensive steelwork. Copper tells a similar story. We have mined it from concentrated ore and spread it across the globe in wiring, electronics, and pipes. Left unattended, copper oxidizes and leaches into soil and water. Over deep time, it too is transported, buried, and incorporated into new sediments. But it is not destroyed. Chemical processes can rearrange it, but they do not remove it from existence. A future investigator might see a brief, planet-wide pulse of copper concentrations within a narrow layer of rock, too broad and thinly spread to be a simple ore deposit, hinting instead at some unnatural redistribution. Then there is combustion. Our technological age depends heavily on burning coal, oil, gas, biomass. Each ton of fuel burned injects carbon into the atmosphere and oceans, changing isotope balances that will later be locked into carbonate minerals and organic-rich sediments. To future geologists, the interval we live in will stand out as a sharp, rapid excursion in certain isotopic ratios. Just as we now see the iridium boundary as a mark of impact, they would see our carbon anomaly as an unmistakable sign of something abrupt and powerful. Even plastics, easily dismissed because they break down so quickly in the environment, have a potential long-term legacy. Exposed to sunlight and mechanical wear, they fragment into microplastics and nanoplastics, tiny particles that drift with currents and winds. Some of these will settle in deep, low-oxygen environments on the ocean floor, where decomposition is extremely slow. Over geological timescales, those fragments might become encased in sediments, leaving behind either microscopic remnants or distinctive hydrocarbons embedded within rock. If this is true for us, it might have been true for anyone before us. Their fossilized fire and steel might not be literal fire or steel at all, but their equivalents, whatever energy sources and structural materials they relied upon, we might already be walking on transformed traces of such materials without realizing they are anything other than unusual rock. Of course, it is entirely possible that no such civilization ever existed. It is equally possible that if one did, its residual signatures were destroyed beyond recognition by the very processes we have been describing. Time is not generous with survivors, yet that is exactly why the search for these deep, subtle traces is important. It is not just about solving a mystery. It is about learning how to recognize the geological footprints of intelligent activity, ours and anyone else's. In seeking the hypothetical remains of someone who might have come before, we also clarify what our own eventual remains will look like. We are, in effect, studying our future archaeology as much as any imagined past. What we see is humbling. Everything we regard as durable and grand, our infrastructure, our technology, our cultural artifacts, will be reduced, in the very best case, to narrow bands of altered chemistry and rock layers and deep sediments. And yet there is a strange consolation in this. Even if the Earth will one day forget our languages and stories, it will not forget us entirely. We will be part of its structure, folded physically into its long geologic memory. If there were predecessors, they too are present in some form, even if only as unexplained peculiarities in mineral deposits, or as fleeting anomalies in data we have not yet learned to interpret. Every rock we crack open, every deep-sea core we analyze, is therefore more than just a sample. It is a question, a chance to catch the faintest echo of worlds that might have existed and vanished long before ours began, and a preview of the echo we ourselves will leave when we are gone. If the Earth buries its secrets in stone, deserts are among its quietest vaults. There is something about the unbroken lines of dunes and the low hiss of shifting sand that feels outside of ordinary time, as if nothing has changed there for ages. But deserts are not empty spaces. They are places of accumulation and concealment. They are where the world tucks things away under layers of dust and sand, smoothing the surface until all that remains is apparent simplicity. Even within our short human history, we have watched this process unfold. Entire settlements have been covered by dunes in a matter of centuries. Thriving caravan hubs in North Africa, oasis towns choked by encroaching sand, temples abandoned when rivers shifted course and the surrounding land dried, gradually disappearing beneath wind-blown drifts. The desert rarely obliterates such places with violence. It envelops them. It lays itself over them grain by grain. It waits. In only a few thousand years, barely a blink, geologically structures that once echoed with voices can vanish completely from view. Now extend that transformation to the scale of millions of years. Landscapes rise and fall. On the edges of continents, seas may retreat, leaving vast plains exposed to arid winds. Over time, new deserts are born. They cover whatever stands in their path. Forests, rock art, the remains of animals, or any traces of earlier cultures. Under enough sand, shielded from water and plant roots, those buried layers might be preserved in surprising ways. This dual nature makes deserts peculiar, but important in any search for deep history. On the one hand, their surfaces are constantly reshaped. Sand abrades, etches, and buries man-made structures and natural outcrops alike. On the other hand, once something is deeply enough entombed, the desert can protect it for a very long time. Dryness halts many of the usual processes of decay. There's little biological activity to break things apart. The result can be a time capsule, provided the material has sunk far enough below the active layer of shifting dunes. We have already discovered remarkable preservation in arid regions. Texts written on papyrus, preserved because rain never reached them. Textiles and wooden artifacts that would have rotted away anywhere else. Footprints and trackways hardened into crust and left untouched because no later weather disturbed them. Multiply that effect across millions of years. Beneath modern deserts such as the Sahara lie rocks, hundreds of millions of years old. Much of that underlying surface has been geologically quiet over vast spans of time. if a civilization or some earlier unknown style of organized life once existed in such regions before they became deserts, any surviving trace would not be at the sunlit surface, but deep in those older layers. Such traces would not resemble intact cities. Time and pressure would have long ago altered their materials. Buildings and tools would have become part of the rock record. Perhaps unusual conglomerates of metals, ceramics, or altered organic residues now indistinguishable at a glance from natural stone. They might exist as barely noticeable changes in mineral composition where large amounts of resources were once concentrated and then abandoned. The scale of these vaults is sobering. Desert basins can be enormous. Our current exploration ground surveys, excavations, remote sensing barely scratches the uppermost strata. Much of what lies tens or hundreds of meters below remains untouched and effectively invisible to us. That is why deserts invite speculation. Their silence is so complete that it pushes us to wonder what might lie beneath. Each time shifting sands briefly uncover an ancient roadway or temple, we are reminded that empty landscapes sometimes hide complex histories. If deserts can do this for a few thousand years of human past, one cannot help but ask what they might have been doing with much older chapters of the Earth's story. We may never dig deeply enough, widely enough, or cleverly enough to find out. The planet is large, and our tools, while improving, are still limited. But the mere possibility changes how we see those endless dunes. They cease to be blank spaces on the map and become sealed rooms in a vast archive. If someone else left something here in a forgotten age, then the desert is one of the few places where fragments of that presence might still be hidden, waiting beneath the sand's shifting surface. If deserts are the planet's sealed vaults, then the oceans are something stranger still. They are its true archive, immense, dark, and almost untouched by ordinary weathering. While wind, ice, and rain scrape and refashion the continents, the deep ocean simply receives what falls into it and slowly lays it down. Most of the Earth's surface lies underwater, and yet we know relatively little about what rests on the seafloor. We have rough maps that show mid-ocean ridges, abyssal plains and trenches, but most of that terrain has never been visited directly, and only small volumes of sediment have ever been sampled. This is precisely why the deep ocean matters so much to the question of hidden histories. If remnants of a forgotten industrial age survive the slow destruction of continents, it is here, beneath miles of water and mud, that they would most likely be preserved. On land, erosion is constant and aggressive. Mountain peaks are carved down, valleys are widened, glaciers scour the bedrock, and rivers carry rock fragments away. Even hard stone is eventually fractured, dissolved, or metamorphosed. But far below the ocean surface, in the perpetually cold and still depths, conditions are different. There is no rain. There are no storms powerful enough to scour the bottom at great depth. There are very few organisms that burrow and churn the sediment on large scales. Instead, the deep ocean floor experiences a slow, nearly uninterrupted rain of tiny particles. Dust blown from continents, microscopic shells of plankton sinking after death, ash from faraway eruptions, soot and organic debris from the upper waters. These particles settle out, forming thin layers that build up over hundreds of thousands and millions of years. Because of this, deep-sea sediments preserve an unusually continuous record. When scientists extract long cylindrical cores from the seabed, they unroll a timeline of the planet's climate and chemistry. Within those cores are clues to glacial cycles, changes in ocean circulation, bursts of biological productivity, and mass extinction events. If an earlier technological civilization left any planet-wide signature, we would expect to find hints of it not on mountaintops or in buried buildings, but in those layers of ocean mud. What might those hints look like? Not sunken cities. The deep sea is not gentle with large structures. High pressure, corrosion, and geological activity around ridges and trenches would break them down and bury them quickly. Instead, the traces would again be chemical and particulate. a layer richer than normal in certain industrial metals distributed across wide areas of the seafloor. An abrupt shift in carbon isotope ratios that could only be produced by the rapid release of large quantities of stored carbon, perhaps rare, degraded residues from complex synthetic molecules preserved in low oxygen environments where degradation is slow. Even then, these signals would almost certainly be faint. They might occupy only a few centimeters within a core representing millions of years. Many cores would yield nothing unusual. One could spend decades sampling and never encounter the critical horizon. But if something from a very distant technological past is still detectable, the deep ocean is where its last, quiet imprint is most likely to lie. What makes this even more humbling is how little of this archive we have touched. Oceans cover over 70% of the Earth's surface, yet only small portions have been explored in detail. In some respects, our maps of the Moon and Mars are more complete than our maps of the deep seafloor. That is why the question remains wide open. The signals we are wondering about may simply lie outside the handful of places we have drilled or dredged. We already know this archive holds evidence of dramatic events. The thin clay layer that marks the asteroid impact which ended the Cretaceous is among them, as are traces of enormous volcanic eruptions that smothered the planet in ash and gas. Changes in ocean chemistry that accompanied past climate shocks can also be read there. These signals remain intact because nothing has erased them. They sit, undisturbed, under additional layers of sediment, insulated from much of the tectonic turmoil that reshapes continents. If such things can persist, then so might the residue of an earlier industrial age. Not the age itself, no buildings, no ships, no machines, but the brief chemical disturbance it caused. That is enough, in principle, to tell us that something unusual once happened. So the ocean becomes more than a wilderness. It becomes an enormous, mostly unread ledger. Every wave that breaks along a shore is linked, however distantly, to that ancient record lying in darkness far below. The seas have been storing their secrets for a very long time. If one of those secrets is that an intelligence rose, changed its world, and disappeared long before we existed, the deep ocean would likely be the last and best place where its fading mark remains. To fully appreciate how much the Earth can conceal, you have to perform a mental reversal. Instead of letting time flow forward, you imagine rewinding it. Peel away years, then centuries, then millennia. Watch human structures dissolve and vanish. The first layers of our own history disappear quickly. A few thousand years rolled back, and every modern building is already gone. Forests reclaim what were once cities. Rivers reoccupy their old floodplains. In 100,000 years of backward time, not even scattered debris from our civilization is left on the surface. Every trace we see now, roads, dams, bridges, unbuilds itself, leaving behind wild, shifting landscapes. Rewind further, 1,000,000 years, and the world looks entirely different. Ice sheets advance and retreat over high latitudes. Animal and plant communities shift and rearrange with glacial cycles. The atmosphere changes rhythmically as carbon moves between air, ocean, and rock. Humans vanish from the story well before this point. What remains is a planet in motion, but not a human planet. Keep going. 10 million, 50 million, 100 million years. Continents slide to new positions on the globe. Fresh mountain ranges rise where plates collide, then are gradually eroded away. Entire ocean basins close and new ones open. Volcanic provinces cover vast regions in successive lava flows. The shapes of land and sea transform so completely that it becomes meaningless to ask which region is which. You have gone back beyond the memory of any familiar geography. At this point, the question of earlier civilizations acquires a new gravity. If the world itself changes so thoroughly when time is rewound, what would remain of brief technological episodes separated from us by hundreds of millions of years? Not much. Even the rock layers that would have recorded their existence may have been subducted or metamorphosed beyond recognition. Geologists sometimes describe the crust as a palimpsest, a manuscript scraped and written over many times. In a few rare areas, very old rocks have survived relatively intact. These outcrops, some more than 3 billion years in age, offer narrow windows into remote epochs. Yet even in those ancient stones, The record is fragmentary and heavily edited. Huge intervals are missing, with only key events, sudden changes in atmospheric composition, major shifts in ocean chemistry still traceable. If a civilization had arisen in one of those blank intervals, say 10 million years before dinosaurs appeared or 50 million years after the first complex forest took root, how would we notice? Most likely, we simply wouldn't. Our evidence would be the same as it is now. Broken sequences of rock, intermittent chemical clues, and a lot of silence. The largest mass extinction in the known record, at the end of the Permian period, killed around 90% of species. Yet the physical record of that catastrophe is thin. A few beds of disturbed sediments, some isotopic anomalies, changes in fossil assemblages. If something so world-shattering can be compressed into a handful of ambiguous layers, how much less would survive of a short-lived industrial phase? Running time backward this way also changes how we see ourselves. Our civilization is only a few thousand years old. The fossil fuel-driven phase that could leave clear geological signatures is just a couple of centuries old. On the scale of Earth's history, that is less than a flash. If there were others before us, their window of existence might have been just as brief, their signal just as sharp and short-lived, and now deeply buried under new rock. This is why, in seeking physical evidence of such a civilization, researchers emphasize that any robust sign is likely to be indirect. Clear artifacts, the sort we display in museums, vaporize under deep time. Abnormal chemistry, however, can persist much longer, but even that can look similar to purely natural events. An abrupt burst of carbon into the atmosphere could have come from a massive volcanic outpouring or from the decomposition of buried organic matter. Without strong contextual evidence, it is difficult to distinguish. The conclusion is uncomfortable. The lack of unmistakable signs does not prove that nothing ever happened. It mainly proves that the Earth specializes in erasing. There is another side to this thought, however. If time can so thoroughly dismantle earlier worlds, it will also do the same to ours. 100 million years from now, no one will find intact monuments of our presence. Our architecture, our infrastructure, our art, all will be gone. The continents themselves will be in two places. Mountain belts will have come and gone. Our story will not be remembered in the ways we usually imagine. It will be remembered, if at all, as a faint stratigraphic blip. And in that scenario, we would be on the same footing as any hypothetical predecessors, reduced to a narrow line in stone, another erased chapter among many. Seen this way, deep time is a kind of equalizer. Whether or not anyone else once shared this planet with us, they would now be mostly indistinguishable from us in the Earth's long-term archive. Future intelligences might speculate about us as we speculate about them, knowing that even their most careful investigations could never be completely conclusive. Time is not something that moves for our benefit. We move through it and leave tiny disturbances in its wake. If you run it backward in your mind far enough, you see not just your own civilization dissolve, but all familiar landscapes and forms. In the end, you are left with a planet that has repeatedly cleared itself, ready again and again for new stories. If there is one constant through all of this, it is that the Earth has always been speaking. Not in languages we use, not in human sounds, but through a slow vocabulary written in minerals, textures, and buried chemistry. Our challenge has never been that the planet keeps no record. The challenge is that we are new, and we are still learning how to interpret what we see. Most people pick up a rock and see only something inert and opaque. To a trained eye, that same rock is a densely packed page. Its color and grain say, whether it formed from lava, sand, or mud. The alignment of its crystals can hint at the pressures and temperatures it has endured. Tiny fossils or mineral inclusions can reveal whether it once lay beneath a sea at the heart of a mountain or on the floor of an ancient lake. A block of sandstone, for instance, is not just stone. It is a frozen slice of an old shoreline, riverbed, or desert. A thin layer of volcanic tuff is not just hardened ash. It is the time-stamped product of a particular eruption. To geologists, the Earth is full of such condensed stories. Ice ages, megafloods, sudden extinctions, they are all written down, but in a script that took us generations to begin deciphering. Any trace of a civilization older than ours would be composed in the same language. Its letters would be rare element concentrations, altered isotope ratios, and perhaps odd organic residues. A single thin bed enriched in certain metals. A short-lived anomaly in carbon chemistry across multiple locations. A scattering of molecules that look unlike anything produced by ordinary geology. These would be the only genuine words such a civilization could reliably leave for us under the pressure of deep time. Their monuments would vanish. Their chemistry would not, at least, not entirely. This is why the Earth is at once a destroyer of memory and its most faithful keeper. It obliterates obvious forms, the statues and towers we instinctively imagine as history, yet retains the underlying signals of change. The asteroid that ended the age of dinosaurs did not leave surviving shards for us to examine easily. But its presence and impact are unmistakable in that one persistent iridium-rich horizon. If we were to vanish, the same pattern would hold. Our story would be preserved less through the survival of buildings than through the residue of our activity, captured in sediments as a global pulse of altered chemistry. Future investigators would see not our faces, but our fingerprints. Now turn that image backward in time. Think of a layer in very old rock that behaves strangely under analysis. It has an odd mix of metals or an unexpected isotopic pattern. Right now, we might label it as the product of some unknown or unusual natural process and leave it at that. But there is always the tiny nagging possibility that in a few cases, the process we do not yet understand could be the dying echo of an old technological age. This is the difficulty of reading the planet's language. It whispers. Its signals are quiet. They are easy to mistake for background noise or write off as trivial. In many cases, that is exactly what they are. But we cannot be entirely sure in every instance. We are also constrained by access. The accessible rock record is like a small shelf at the edge of a massive library. Most of the books remain sealed deep in the crust, unreachable with current technology. We know just enough to be sure that a vast amount is missing. Yet, there is a certain beauty in this limitation. Even though we will never read every page, we know the archive exists. We know the Earth remembers events and processes over unimaginable spans of time. And if anything like us came before, there is reason to think that some shadows of their presence would still be encoded somewhere in this vast, unfinished text. Every new core sample, every high-resolution survey, every improved analytical technique is effectively a way of listening more closely. One day, such listening may unearth a signal we cannot easily fold into known natural processes. If that day comes, it may be the closest we ever get to hearing from a civilization erased by time. The question is whether we will notice that signal when we see it, or whether, as so often in the past, it will sit quietly in our data, waiting for someone to ask a new kind of question. Every so often, as we peel back the layers of the Earth's past, we stumble upon something that does not seem to fit at first glance. An artifact recovered from deep strata that appears too advanced for its supposed age. A pattern in rock that looks deliberately shaped rather than naturally formed. These finds are often grouped under the label out-of-place artifacts. Most of them, when carefully examined, resolve into ordinary explanations. A supposedly ancient tool turns out to be a modern object that somehow became encased in younger concretion. A mysterious pattern is revealed to be a crystalline structure, or the product of normal weathering. The apparent anomaly dissolves under closer study. One well-known example is the so-called London hammer, a hammer-like object found within a chunk of stone. Sensational accounts claim the surrounding material was many millions of years old, implying impossible antiquity for the tool. More detailed analyses, however, showed that the stone around it was a relatively recent concretion made of minerals that had precipitated around the hammer's head. The hammer itself was historically recent. The mystery was more about unusual geology than about lost civilizations. Stories like this play a familiar cycle. They emerge as exciting challenges to established history, then gradually lose their allure as mundane explanations triumph. Yet the broader idea they evoke persists in the public imagination. What if, even once, such an object truly did not belong? Most scientists remain cautious, rightly so. Individual artifacts, especially those without secure context, are unreliable guides to deep time. Yet behind the caution lies a concession. Our record is drastically incomplete. For every bone or tool that survives in datable layers, countless others have been obliterated or remain undiscovered. If there were truly anomalous objects from a forgotten age, they would be exceedingly rare by now. But exceedingly rare is not the same as impossible. The Silurian hypothesis reminds us that if an earlier technological species did exist, its durable remains would be scattered and transformed. Its metalwork might end up as unremarkable lumps of alloy, heavily corroded and altered. Its engineered materials might be reduced to mere chemical residues inside old minerals. These wouldn't look like clean, recognizable devices. They would look like odd, often microscopic deviations in otherwise normal rocks. Even today, we encounter items that provoke debate. Spherical, grooved, iron-rich nodules from certain South African mines, for example, have been cited in fringe narratives as artificial. Geologists see them as natural concretions formed by slow processes inside the Earth. Their symmetry and grooves can arise from regular growth in a constrained environment. To most researchers, this is where the discussion ends. But the persistence of such questions is not just about the specific objects. It is about the edge between the known and the unknown. If the Earth did hide the remnants of an extremely ancient civilization, what would those remnants look like? They might not stand out at all to our current way of seeing. We are used to recognizing artifacts that look like ours bones, pots, worked stone. A truly alien set of remains, even if homegrown and terrestrial, might not trigger that recognition. Our minds are biased toward familiarity. When we see a carved statue, we register intention because it resembles forms we ourselves make. When we see a symmetrical metal piece, we think of tools. But if an ancient civilization's materials and designs bore little resemblance to our own, we might walk past them without a second thought. They would just be rocks. That is why the search for out-of-place artifacts, however often it leads to dead ends, still highlights an important point. The boundary between natural and artificial is not always obvious at first glance. As our analytical tools become more sensitive, we are beginning to find signals and patterns that would once have been invisible to us. Strange isotopic ratios, subtle structural anomalies at the microscopic scale, unusual combinations of elements. If genuinely anomalous artifacts from deep time exist, they will likely make themselves known not through dramatic discovery, but through quiet inconsistency in data. A sample that does not conform to expected geological histories. A pattern of trace elements that resists natural explanation across multiple tests. The first credible sign that we are not the first might not be a spectacular object, but a persistent statistical oddity that refuses to go away. Should such an anomaly ever be found and verified, it would not merely adjust a timeline. It would fundamentally alter how we see ourselves. We would no longer be the sole technological story on this world, but one in a series separated from our predecessors, not only by time, but by the near-total erasure the deep time imposes. Until then, our strange finds mostly teach us to be patient and thorough, to question assumptions, and to refine our understanding of what nature can do, unaided. But they also serve as reminders that the Earth has had a very long time to produce both the ordinary and the extraordinary, and that somewhere in that vastness, there may still be things we do not yet know how to recognize. When we picture a civilization, we instinctively think on a grand scale, towering skylines, sprawling road networks, monumental structures visible from far away. But this picture is shaped by our own form and our own way of living. Intelligence need not look like us, and a civilization need not be massive or obvious to have existed. Life on Earth has long favored the small over the large. For most of the planet's history, microscopic organisms have dominated. They live in every conceivable niche, from boiling hydrothermal vents to deep subsurface rocks, from polar ice to the upper atmosphere. They vastly outnumber larger animals and plants in both individual count and total biomass. We often call these microorganisms simple, but that may be more a reflection of our ignorance than of their true complexity. Bacteria and archaea communicate through chemical signals, organize into colonies, build intricate biofilms, and even exchange genetic material horizontally, sharing useful traits with extraordinary efficiency. They manage resources and respond collectively to stress in ways that, at large scales, resemble problem-solving. If intelligence can manifest in many forms, it is not unreasonable to wonder whether something like a civilization could arise at microscopic or distributed scales. Not a civilization of skyscrapers, but one of networks vast, thinly spread, and mostly invisible to creatures like us. Imagine a world where minds are not concentrated inside skulls, but distributed among trillions of microscopic entities. Coordination could happen through chemical gradients, electrical signals, or patterns in shared genetic exchange. Structures might be grown rather than built. Technology, if it existed, could be biochemical rather than mechanical. A civilization of this kind might never need to produce large, durable artifacts. Its cities could consist of complex, layered microbial communities in soils, sediments, or shallow waters. Its main achievements might be large-scale modifications to its environment, tuning atmospheric gases, reorganizing nutrient cycles, altering the chemistry of oceans and rocks. To us, those changes would look like natural planetary processes. If such an organized biosphere arose and then collapsed tens or hundreds of millions of years ago, what would we see now? Perhaps nothing we would recognize as artificial. We might see an abrupt change in certain elements or compounds within ancient sediments, a spike in molecular byproducts that do not appear before or after that interval, a short-lived diversification of particular microfossil forms that later vanished. In other words, the traces of a microscopic civilization would probably blend into the background of biological and geological activity. Distinguishing purposeful alteration from the planet's own natural feedbacks would be extremely difficult. Yet in principle, it is conceivable that some ancient, globally organized biological system once reshaped the Earth in ways we now attribute solely to anonymous life, rather than any kind of organized agency. This thought does not demand that such a system actually existed. It simply broadens our sense of what civilization could mean. Our definition is deeply anthropocentric. We look for fire, tools, metal, and a monumental architecture. But there may be other thresholds of complexity, other ways for life to become self-aware, coordinated, and world-shaping that leave behind only the quietest marks. And in thinking about those possibilities, we are forced to recognize how narrow our search image has been. If we want to detect non-human civilizations in deep time, we may have to learn how to read hints written in the biology and geochemistry of the planet, rather than in stone walls or metal fragments. We may already have glimpsed such hints without recognizing them. Ancient microbial mats that seem surprisingly sophisticated, puzzling chemical shifts in very old rocks, complex fossilized structures whose exact origins remain debated. None of these is proof of a microscopic civilization, but each represents a question. And sometimes, questions are more important than quick answers, because they push us to devise new tools and new perspectives. If civilizations in miniature are possible, then their rise and fall would be gently folded into the planet's background processes, with almost nothing on the surface to mark their passing. Their memory would be preserved, if at all, only in the fine print of the Earth's chemistry and in the structure of ancient microfossils. Invisible, however, is not the same as non-existent. For all we know, the planet beneath us might already contain such memories, etched so lightly that we have not yet understood what we're looking at. From there, it is not such a leap to an even stranger idea, that life, in general, has been engineering the Earth in ways we are only slowly beginning to understand, and that some of those engineering projects might be so profound and long-lasting that we no longer recognize them as the work of living things at all. For as long as our planet has had life, it has had architects. Not architects like us, with drawings and contracts, but systems of organisms whose combined activities have reshaped air, oceans, and crust. Cyanobacteria, for example, transform the atmosphere by releasing oxygen as a waste product. In doing so, they poisoned many older life forms, but opened the door to more complex organisms, including us. Over immense spans of time, their unintentional project rewrote the planet. Coral reefs are another form of life-built structure. Tiny animals construct huge carbonate edifices that, taken together, can stretch for hundreds of kilometers. Reefs alter currents, form natural barriers, and create habitats for countless other species. Should they vanish and later be fossilized, a distant intelligence might reasonably wonder whether they were natural or intentionally constructed. These examples are not evidence of technological intelligence, but they illustrate an important point. Life does not merely adapt passively to a given environment. It can collectively modify that environment in enormous ways. The line between natural geology and biological engineering becomes blurred. Now imagine pushing that principle further back and further up in complexity. Suppose there once was a form of life that over millions of years deliberately or semi-deliberately reshaped parts of the crust, atmosphere, or oceans. Not with metal tools, but with biology, controlling mineral deposition, rerouting nutrient flows, changing climate regimes. Its works, after enough time, would harden into apparently natural rock formations. Its footprints would be the mountains, sediment beds, and chemical cycles we now see as background geology. In that scenario, a civilization's legacy would be nearly indistinguishable from the planet itself. The Earth would not just hold the memory of its existence, it would be the memory. The structures in question would be geological formations we walk on and study, never realizing they bear the imprint of long-vanished design. We already treat some massive changes in Earth's history as purely geological, even when life clearly played a role. The Great Oxidation Event is now widely understood to have been driven by photosynthetic organisms. Yet, in the rock record, it appears as a change in mineral assemblages and isotope ratios. If we did not know that life was involved, we might interpret it solely as an exotic chemical cycle. It is not far-fetched, therefore, to ask whether there are other large-scale transitions in the rock and geochemical record that involve feedbacks from life in ways we don't yet recognize. These might be the signatures of evolution exploring different organizational structures, perhaps even brushing, however briefly, against forms of complexity we would regard as civilization-like. We may never be able to resolve such questions fully. The older the rocks, the more their information content is scrambled by heat, pressure, and deformation. By the time you reach billions of years into the past, the record is more like a palimpsest than a book, overwritten, patched, and incomplete. Still, the notion of forgotten engineers of nature changes how we think about the earlier Earth. Rather than seeing life as a late add-on to an otherwise sterile geologic engine, we can recognize that life and geology have been entwined, co-evolving and co-creating the environment. Somewhere in that deep interplay, there may have been episodes of organization and world-shaping agency that go far beyond what we see in most ecosystems today. Whether or not those episodes qualify as civilizations, in the strict sense, they would represent other ways of being a planet builder ways that ended long ago and were absorbed into the anonymous architecture of the Earth itself. If the Earth keeps this kind of memory in stone and chemistry, humans keep a different kind in story. Long before stratigraphy and isotope analysis, people noticed fossils in rocks, seashells on high mountains, and layers of unfamiliar stone. They saw storms, earthquakes, and floods. Without modern science to explain these phenomena, they wove them into myths. Today we often treat myth purely as fiction or simple allegory. But myths have a way of preserving emotional truths and vague recollections of real events long after the details are lost. Flood legends, for example, appear in cultures across the world. Stories of waters rising, lands drowned, survivors setting out to begin again. We now know that at the end of the last ice age, sea levels rose dramatically. Glacier-fed lakes catastrophically drained, coastlines shifted. For people living close to water, such events would indeed have felt like the end of the world. Over thousands of years, precise memories become blurred, but powerful narratives remain. They are passed down, reshaped by each generation, until they are harder to read as literal history and easier to interpret as symbolic tales. Still, embedded within them may be the faint afterimage of real geological and climatic events. The same may be true of myths about prior ages and lost worlds. Stories of Atlantis, golden ages, cycles of creation and destruction, or earlier races of beings can be read as reflections of a basic intuition: that the world is older than any one culture, that things have risen and fallen before, and that the present is built on layers of forgotten past. We do not need to take these myths literally to appreciate their significance. They show that human beings everywhere have long sensed that the Earth contains more history than they can see. Before we could look to deep-sea cores or ancient zircons for answers, we looked to narrative. Myth was an early form of listening to the planet's strangeness. There is a poetic possibility here. If at any time in our deep prehistory humans encountered uncanny traces of earlier worlds, fossil bones too large to explain, inexplicable ruins from earlier human cultures, or unusual rock formations, they might have encoded their reaction in story, not facts. Those stories could then drift through time, losing specifics, but retaining a core sense that others lived and died before us, and that the world has been remade. Even if no earlier technological civilization existed, that sense is still accurate. Entire evolutionary experiments, dominant species, entire ecosystems have risen and fallen, leaving only partial records behind. The human feeling that we are latecomers standing on ancient ground is, in that sense, absolutely correct. Myths, then, are not evidence in any scientific sense for prior non-human civilizations, but they are a mirror of how people have always responded to the enormity of time. They illustrate that as soon as humans were able to reflect on their surroundings, they felt the weight of past ages pressing in from all sides. As our scientific tools sharpen, we may eventually be able to test, in a limited way, whether some of the great transformations alluded to in myth correspond to specific geological events. We may also find that certain long-standing themes, endless cycles, lost ages, worlds before ours match remarkably well with what we see in deep time. Not because the myths recorded those events directly, but because human imagination, confronted with an ancient planet, naturally gravitates towards certain patterns of thought. Those patterns prepare us, in a sense, for the scientific realization that we are not the first beings to change this world radically, and probably not the last. And they remind us that, just as our ancestors used stories to encode their glimpses of the past, we, too, are telling stories now that may one day survive only in echoes, half remembered by distant descendants or transformed into new myths for a future age. If myth hints at forgotten worlds, entropy explains why they vanish. Entropy is the measure of disorder, the natural drift from organized structures to scattered debris, from readable arrangements to chaos. It is the reason a house, left alone, decays rather than improving. The reason a carefully arranged archive, if neglected, eventually becomes a pile of dust and fragments. At human scales, we see entropy in small, familiar ways. Paint peels, iron rusts, wood rots. Without constant maintenance, anything we build gradually succumbs to decay. On planetary scales, the same principle sings a much slower, but far more thorough song. Mountains level out, coastlines blur and shift, craters fill in. Over enough time, everything tends toward a state where its original form is difficult or impossible to reconstruct. Civilizations, with all their structures and patterns, are islands of low entropy in this sea of gradual dissolution. They require constant input of energy to maintain their order. When that input stops, whether because of internal collapse, external catastrophe, or gradual change, deterioration begins. Picture a planetary scale city under the gaze of entropy and geologic time. The first stages of disintegration happen quickly by geological standards. Buildings crumble, metal corrodes, vegetation invades, animals burrow and nest. After a few thousand years, almost nothing stands. After a million, the site is likely buried or weathered into indistinct topography. Deep time takes things further. Once structures are underground, they are compacted, chemically altered, and sometimes heated enough to recrystallize. At each stage, more of the original information is lost. Details of construction vanish. Even the distinction between natural and artificial material becomes blurred, then erased. Plate tectonics adds another layer of forgetting. Whole chunks of crust are dragged into the mantle, where temperatures and pressures are high enough to obliterate their original mineral structures entirely. In such cases, not only the city, but the rock beneath it ceases to exist in its original form. Given enough time, then, every civilization faces the same ultimate fate: to be transformed into something that no longer obviously carries its imprint. From that perspective, the question of whether there were others before us is transformed. It is no longer, did they leave big things we can find easily? But, is there any circumstance in which their influence could survive long enough to be detectable now? That circumstance, as we have seen, probably involves the stable embedding of unusual chemistry into rock and sediment traces that can endure even as physical structures disintegrate. And even then, the traces might look like nothing more than odd variations in data to someone who is not specifically looking for them. At the same time, entropy has a strange, almost paradoxical grace. While it erases forms, it does not annihilate their substance. Atoms and basic particles persist, cycling through new arrangements. The calcium that once formed the bones of a vanished creature might later crystallize as part of a limestone cliff, or dissolve again into seawater. Likewise, the metals and minerals of our cities will be recycled into the planetary system, becoming raw material for future rocks, soils, and perhaps even future lives. In that sense, nothing is truly lost, only rearranged. What disappears is the pattern, the specific configuration that made a city, a city, a civilization, a civilization. Patterns are delicate. They are what entropy eventually unravels. For us, this realization is both humbling and oddly comforting. It humbles us because it shrinks our long-term footprint to something vanishingly small. However dominant we seem now, however far our signals reach, the Earth's long processes will ultimately dissolve our work into dust, melt, and reconfiguration. We are not exempt from the rules that governed trilobites, dinosaurs, or ancient forests, but there is comfort in recognizing that we are part of a larger, ongoing transformation. Long after our particular arrangements dissolve, the matter that once composed us will remain, helping to write new chapters in the Earth's story. Somewhere, sometime, some future being might stand on rock that once, at the microscopic level, held iron from our bridges or carbon from our atmosphere. Entropy, then, is not just the destroyer of worlds. It is also the mechanism by which worlds change and renew themselves. It clears away the old, making room for the new. If there were civilizations before us, they have passed through that same gate, leaving behind, at best, scattered and partial signs. So will we. The question we keep circling back to is not whether history leaves traces, it does, but whether any of those traces from very ancient, advanced life are still distinct enough for us to recognize. The only way to answer that is to keep looking, with sharper instruments and broader imaginations, not for intact remnants of cities, but for the smallest deviations in the vast entropic flow of the Earth's long memory. If entropy and geological churn erase almost everything, what could possibly endure beyond stone and sediment? Some physicists have suggested that, in a deep and abstract sense, nothing is ever entirely forgotten, that traces of all events remain encoded in the very fabric of reality, even when all visible signs are gone. This idea leads to the notion of a quantum fossil, not a fossil in the ordinary sense, but a residue of history written into the most fundamental physical states of matter. Every interaction between particles slightly alters their configuration. Every scattering of light, every exchange of energy, changes the state of the system in tiny ways. Over time, these changes spread and compound, becoming part of a vast, tangled web of cause and effect. In classical physics, information can be lost. Things mix irreversibly. But in certain interpretations of quantum mechanics, information is conserved even when the macroscopic order disappears. If you had infinite precision and unimaginable computational power, you could, in principle, track those tiny changes backward, reconstructing the path of events that led to the present. In reality, of course, we cannot do this. The information is hopelessly dispersed. The second law of thermodynamics guarantees that these trails are effectively impossible to reassemble. But conceptually, it means that what happens is never fully undone. The universe keeps everything, not as neat narratives or images, but as subtle biases and correlations among particles. For civilizations ours or hypothetical predecessors, this implies that some residue of their existence survives even after their cities crumble, after their planets die, even after their stars burn out. At the most basic level, the arrangement of matter and energy reflects the totality of what has occurred. The memory is not one we can retrieve, but it exists nonetheless. Thinking this way does not help us find ancient civilizations in any practical sense. You cannot hold a quantum fossil in your hand, or scan for it with a detector. But the concept serves as a philosophical counterpoint to the erasure we see in geology. On one scale, nearly everything recognizable is lost. On another scale, nothing is entirely erased. For us, it adds an unexpected depth to the idea of being forgotten. Even if no physical artifacts remain, even if no later intelligence ever discovers a chemical trace of our world, we will still be there in the most literal sense, present in the precise state of everything that follows. Our story will be woven into the background hum of reality, indistinguishable but not absent. If there was another technological age before ours, no matter how long ago, it too would be preserved in this way, not as ruins or fossils, but as minute, irretrievable biases in the configuration of matter itself. The universe would remember it just as it will remember us, in a way that does not depend on any conscious observer. This perspective is humbling in a different way. It suggests that, at the deepest level, nothing we do is truly lost, and yet almost none of it is practically recoverable. We remain, but as part of an unreadable archive. Whatever other civilizations once existed, on Earth or on distant worlds, are also part of that archive, merged into a single, inaccessible record. From that vantage point, the difference between a civilization that leaves towering ruins and one that leaves only a thin chemical line in rock shrinks. Both ultimately become part of a larger, invisible fabric. Both become, in the end, faint notes in a cosmic chord that will continue to resonate long after any particular story is over. If the universe is, in this sense, a perfect but unreadable memory, the Earth is a very imperfect but partially readable one. That is where our hope of finding evidence lies, not in the farthest depths of quantum information, but in the comparatively coarse, tangible signatures left in rock, soil, and ice. And that, in turn, leads us to a final question. If someone far in the future came looking for us, what would they actually find? Imagine an archaeologist, not of today, but of a time millions of years from now. They might be the descendant of our own species, heavily evolved and adapted to a different climate and geography. They might be some new lineage entirely, or even visitors from another system. Whoever they are, they will not see our cities as we see ancient ruins now. The physical forms will be gone. What they will find, if they know where and how to look, is a peculiar geological horizon. A layer of rock a few centimeters thick, perhaps slightly more or less in different places, marking a brief interval when the planet changed unusually fast. Within that layer, they would detect a spike in certain metals, widespread but thin. They would see a distinctive signal in carbon isotopes, indicating a sudden release and redistribution of large amounts of fossil carbon. They might pick up traces of long-degraded synthetic compounds, plastics, and industrial chemicals broken down, but not entirely erased. They might find microplastics embedded in ancient seabed layers, or strange particles of alloy and glass fused by extreme heat. To them, this would stand out as a short, intense anomaly. It would look like a geological heartbeat, sudden, sharp, and then over, sharp. They would know that something happened, something powerful enough to leave a global mark, but brief enough to be confined to a thin stratigraphic band. Would they deduce that this something was a civilization? That would depend on how much they understood about how natural processes work and how many similar records they had already studied. If they found nothing comparable elsewhere in Earth's history, the case that we were technological might be strong. If they discovered multiple such layers, suggesting repeated episodes of rapid industrialization separated by long, quiet intervals, the story would become stranger still. It is also possible that they might misinterpret the signals, just as we might misinterpret any deep-time civilization's traces now. They could attribute the anomalies to volcanic mega-eruptions, unusually rapid methane releases, or other natural processes. They might suspect something more, but lack the context to prove it. Nonetheless, from our present viewpoint, it is this horizon, this thin, chemically unusual layer, that represents our most durable legacy. Not the physical objects we value now, but the planetary scale changes we are imprinting on the Earth. Knowing this brings the whole question full circle. The same kinds of traces we expect to leave behind are precisely the ones we should look for when we ask whether someone came before us. Subtle changes in global chemistry, thin, widespread layers enriched in unexpected materials, short-lived, intense signals that cannot be easily folded into the background patterns of volcanism, sedimentation, or biological change. If we ever do find such a signal from deep time, it will likely be incomplete. We will probably never see clear artifacts or read clear messages, but even the faintest, most ambiguous sign that intelligence once rose, acted, and vanished before us would forever change the way we see ourselves. It would place us in a sequence, not at a beginning. It would imply that the universe, or at least this planet, produces not one story of thinking beings, but many, each brief, each powerful, each largely erased. In that light, the silence around us becomes less a sign that we are alone, and more a reflection of how thoroughly time erases its scribbles. Other civilizations might have come and gone, here and elsewhere, leaving only thin scars in rock and slight biases in the state of matter. We do not see them now for the same reason no one will see us later, because nothing stands against the combined work of entropy, geology, and deep time. And yet, something does remain, a whisper in the stone, a pattern in the chemistry, a conceptual memory in the fabric of the cosmos itself. When we listen for that whisper, whether in Earth's rocks or in the light from distant planets, we are really listening for our own reflection. The knowledge that our story, too, is part of something larger and older than we can fully grasp. If they were here before us, we will not meet them. We will not walk their streets or read their books. But we may, if we are very careful and very patient, detect the faintest outline of their passage. And in doing so, we will see our own future more clearly. A thin line in stone, a small shift in chemistry, a fading resonance in the larger music of the universe. Standing in that awareness is not defeat. It is a form of connection to the Earth, to time, and to whatever other minds may have flickered briefly against the dark and then gone out. We too are such a flicker, but for the moment, we are here. We can ask these questions. We can read, however imperfectly, the traces before us. And we can decide what kind of trace we wish to leave behind for whoever or whatever comes next. If other civilizations truly did rise and fall on this world long before we appeared, we would almost certainly not recognize them in any direct way. We wouldn't find streets, statues, or legible tools. Everything obvious would have been ground down, buried, or transmuted. What would remain would be indirect, ambiguous, and easy to overlook. Their presence would persist, if at all, as faint deviations in the deep record of the Earth. A short-lived chemical disturbance, an unusual pattern in sediments, a scattering of metals where no ordinary geology should have placed them. To us, these would look like puzzles in the data, small anomalies that stubbornly resist simple explanation. And perhaps we have already seen some of those puzzles. They may sit quietly in old drill core reports, in tables of isotope ratios, or in the footnotes of papers that mention unusual measurements whose causes are uncertain. They might be archived on hard drives and in filing cabinets, unrecognized for what they could be. In a few cases, they might have been dismissed as experimental error, contamination, or statistical noise. Recognizing such a signal as the fingerprint of an ancient civilization would require more than one odd sample. It would demand repetition, consistency, and a pattern stretching across multiple sites and lines of evidence. It would also require us to imagine explanations that go beyond our current catalog of natural processes without leaping to unwarranted conclusions. This is not easy. We are used to seeing ourselves as the only technological species this planet has ever produced. Every discipline from archaeology to geology to evolutionary biology is built on that assumption. To seriously entertain the idea that someone came before us would mean re-examining a great deal of what we think we know. Not to discard it, but to ask whether there might be room within it for something more. The truth may well be that there was no one before us, that Earth's long pre-human story contained only non-technological life, however strange and varied. The evidence we have today is certainly consistent with that view. But the key realization is that on a planet this old, with a record this incomplete, we cannot yet turn that consistency into absolute certainty. We stand near the beginning of our ability to read deep time. We can date rocks, reconstruct past climates, and identify mass extinctions. We are learning to read the chemical signatures of ancient events. But compared to the complexity of the planet's full history, we are still novices. That is why the idea of forgotten civilizations matters, even if it ultimately proves to be wrong. It stretches our imagination just far enough to show us where our knowledge ends. It forces us to ask what kinds of evidence would actually convince us if such civilizations had existed and whether our current methods are good enough to see that evidence. In doing so, it also reframes our sense of ourselves. Whether or not we have predecessors, we are certain to have successors, or at least, we are certain that the Earth will continue after us. One day our cities will crumble, our languages will fall silent, our data will be unreadable or gone. Long after that, the continents themselves will move, mountain ranges will rise and erode, and the traces of our particular moment will thin and scatter. Eventually, we too will become invisible at the surface. What remains of us will be a quiet pulse in the rocks and sediments, a global layer just unusual enough to say, to anyone who knows how to listen, that something once happened here. And perhaps far ahead, another intelligence will stand on this world, or on some other, and wonder about their own uniqueness. They may drill cores, take measurements, and puzzle over small anomalies. They may ask themselves whether they are truly the first. And as they do, they will be asking the same question we are asking now, only from the other side of our own vanished age. In that sense, we and any hypothetical predecessors or successors are joined, even if we never meet. We are all brief concentrations of complexity in a universe that tends toward dispersal. We are all attempts, however fleeting, by matter and energy to know themselves. If there were others before us, we carry them forward in two ways. First, physically, in the recycled atoms and minerals that now form our bodies and our world. Second, conceptually, in the questions we ask about time, memory, and the possibility of lives and stories beyond our own. If there are others after us, they will, in turn, carry some part of us forward, whether they know it or not. They will inherit a planet and a cosmos subtly altered by our passing. They will invent their own myths about what came before, just as we have. And perhaps, with better tools and deeper insight, they will be able to read the Earth's memory more clearly than we can. For now, we live in a rare moment, a time when we are still here to ask, to explore, and to choose how we will leave our mark. We know enough about the Earth to realize that nothing material we build will last forever. We know enough about time to see that we are a thin layer in a very thick book. We do not know whether there were chapters before us that looked anything like ours. But we do know that our chapter is being written now in stone, air, and water. That knowledge gives us a responsibility, as well as a wonder. We can decide whether the layer we leave behind will be a scar of waste and collapse, or the first sign of a species that learned to live within the limits of its world. We can treat the Earth not just as a resource to be used up, but as a shared living archive of which we are briefly a part. If we are not the first, then we are part of a longer pattern of rise and erasure. If we are the first, then what we do now will shape the conditions for all who might come after us, here or elsewhere. In either case, the weight of deep time does not make us insignificant. It gives our moment context and depth. We walk on a world that has carried countless beginnings and endings. We look up at a universe that may have done the same on scales we can barely imagine. And yet, here we are, able to wonder about it, able to listen for whispers in the stone and the sea, able to imagine stories older than memory. Perhaps in the end, that is the most remarkable trace we will leave. That for a brief time, in one small corner of the cosmos, matter arranged itself into minds curious enough to ask whether they were alone, and honest enough to accept that the answer may always be written more in the quiet language of earth and sky than in words we can fully understand. If you listen closely, in that quiet, you can almost hear it. Not an answer, exactly, but an invitation. To keep looking, to keep asking, to remember that we live on an ancient, patient world that has seen more than we can know, and that our own story, whatever its length, is now part of that vast and ongoing memory